Okay, hi class. Alright, good morning. Okay, so today, we will learn. We continue, right, for topic 2.6 force and also 2.7 impulsive force. Okay, so first we see what is actually a force. Okay, so force is a push or pull. Okay, so that is what is the meaning for that is the meaning for force. So they say in the exam, they ask you what does it mean by force. So push or pull. Okay, so this one we use of forces, okay, in our daily activities. Okay, so forces can make things move. Okay, it can slow down or stop a moving object, and it also can change the direction of moving object, and it can change the shape of an object, and also it can resist other forces. Okay, so this is what force can do. Okay, so the next one, state effects of unbalanced force. So what is the effect? Okay, what happens if the force is not balanced? Okay, so first one, okay, it can move or stop an object. Okay, and it can make the object, okay, move with acceleration, or it can decelerate. Okay, and another one is they can change the direction of an object. And the next one is to change the shape of an object. So this is the effect. What happened, okay, if the force is not balanced. Okay, so for this one, diagram A shows a force F, okay, that acts on an object of mass M. Okay, what will happen to the object? Okay, so the object will accelerate. Okay, so the object will accelerate when you push. Okay, when you push the cart. Okay, so it will move. Okay, it will start moving. Okay, with acceleration. Okay, and then what happens if the force acting on the same mass is double? Okay, as shown in the diagram B. So before this, only one people, okay, that push the cart. Okay, but for the next one, for B, there are two people, right, that push the cart. Means the force is double. So what will happen? Okay, it will accelerate more. Okay, the acceleration will become higher. And then the next question, state the relationship between the force and also the acceleration. So it's directly proportional. Okay, so means when F increase, A also increase. When the force increase, the acceleration also will be increased. Okay. So the next one, what happens if the same force F acts on mass of 2m as shown in the diagram C? Okay, so now, okay, only one person, okay, the first one, it push only one mass only. Okay, so let's say I just put the value of the mass here 1 kg. Okay, so when you push the cart, okay, so it still move with the acceleration. Okay, and then after that, we double the mass. So means it become 2 kg now. Okay, so what will happen? The acceleration, it will decrease, right? So the acceleration will decrease. Okay, so state the relationship between the mass and also the acceleration. So it is inversely proportional. Okay, so means when the mass increase, okay, the acceleration will be decrease. So this is inversely proportional, right? So from the result that we just, from the activity that we just discussed just now, okay, so we can conclude, right? So we can conclude the acceleration is directly proportional. Okay, for a moment. Okay, the acceleration, okay, is directly proportional, okay, to the applied force. Okay, so this is A is directly proportional to F. Okay, with the M is constant. Okay, just now you can see here we constant the mass here, right? Okay, so you get one equation here. Okay, then another activity that we just discussed just now, right? We double the mass. Okay, the acceleration is inversely proportional. Okay, the acceleration is inversely proportional to the mass. Okay, the acceleration is inversely proportional to the mass when you constant the force. So in the diagram, you can see we constant the force. We only use one people to push the cart. So means the force is constant. Right? So this is the equation that we get. Okay, then by combining Okay, so we combine these two equations. Okay, for a moment. So if we combine, okay, A is directly proportional to M, but inversely proportional to M. Okay, sorry, A directly proportional to F, okay, but inversely proportional to M. Okay, therefore we can say that F is, okay, this one is divide, then we change here, it become multiply, right? So F is directly proportional to M A. Okay, so this is the equation. Okay, so the next one, you have to complete the graph. Okay, so this is the graph for A against F. Okay, acceleration against force. Okay, acceleration against force. So you can see here, when the force is increasing, okay, when the force is increasing, the acceleration also will increase. Okay, and then what about A against M? Okay, so A against M is acceleration against mass. Okay, from the activity that we just discussed just now. Okay, when the mass is increased, the acceleration is decreased. So this is the graph for the inversely proportional. Okay, this one you already learned in chapter 1. Okay, so this is the graph of inversely proportional. Okay, and then remember, okay, if the graph is inversely proportional, the x-axis, if you change the x-axis to 1 over m, it will become directly proportional. Okay, so for now, A against 1 over m is a directly proportional. Okay, so means when the acceleration, okay, acceleration against 1 over m, 1 over mass, okay, you will get, okay, the relationship is directly proportional. Okay, so this one, you have to remember the graph. Alright, but be careful of the x-axis here. Okay, you have to see whether the x-axis is mass or 1 over mass. Okay, so if 1 over mass, then it will become directly proportional. If it's only mass, it just become inversely proportional. Alright, so this one we got the equation just now from here. Okay, right, from here. Okay, this one we conclude from the activity that we just discussed. When the force is increased, the acceleration increase, right? We use 2 people to push, right, the cart, and another one we just only use 1. You can see if you use two people to push the cart, the acceleration increase. So we can conclude that when the F increase, the A also increase. Okay, and then another one, okay, we use the same people, only 1 people, right, to push the cart. Okay, but now we double the mass. Okay, for the first time, we only use M. Okay, like let's say I just replace M is 1 kg, and then after that I double the mass, so it become 2 kg. So you can see the acceleration. Okay, the acceleration will decrease, right, when the mass is increased. Okay, so that one become the inversely proportional. So when I combine the equation, it will become like this. Okay, I combine these two. Okay, if we come like this, then I just move here. This one is a divide m, right? So divide m and you combine, you go here, it become multiply. So F is directly proportional to M A. Okay, right? So that is the equation that I get. Okay, so from here, so I already discussed. Okay, from the equation that I just got just now, that F is directly proportional to M over A. So this one, A is actually the acceleration. And we already know the formula for acceleration is, okay, the acceleration is V minus U divided by T. Final velocity, okay, minus initial velocity divided by time, okay, is a A. So I just replace acceleration with the formula of the acceleration. So you will get like this. Okay, and then I just expand. Okay, expand the equation. So it become mv minus mu divided by t. Okay. So what you can conclude here. Okay. So mv minus mu here. Mv minus mu here. This is same as the change of momentum. Right? Change of momentum. Because this one is a final momentum. Okay, because there is a final velocity. Okay, and then this one is the initial momentum. Okay, because they use the initial velocity. Okay, so this one is the change of momentum. Final momentum minus initial momentum. Okay, that is a change of momentum, right? So the change of momentum, and you divide it by t, right? So t is actually time. So if you put in words, okay, it become rate of change of momentum. Okay, so this equation will become rate of change of momentum. Any equation that divide by time, it will have the rate, okay, as the meaning. So let's say, for example, just we do a little revision, right, for velocity, right? So velocity is s divided by t, correct? So what is the meaning of the velocity? Rate of change of displacement, right? Rate of change of displacement. So you see here, rate and is divide. Any equation that divide by t, the meaning we start with rate. Okay, and also another one, this one, v minus u divided by t. So this is what? This is the rate of change of velocity. So if people ask you what is the meaning of the acceleration, rate of change of velocity. This is the change of velocity, and it divide by time. So means rate of change of velocity. Like that. Okay, so for this one, it divide by t, it become rate of change of momentum. Because my mv minus mu is actually the final momentum minus with the initial momentum. So there will be a change of momentum. So change of momentum divided by time, if you put in words, it will become rate of change of momentum. Like this. Okay, so the next part, so from this equation, okay, we conclude, right? We can state that we can learn, right? We can learn the Newton's second law of motion. That is, the rate of change of momentum is directly proportional to the force. Okay, wait for a moment. Okay, the rate of change of momentum, this one, this is the rate of change of momentum, is directly proportional to the force and act in the direction of the applied force. Okay, so let's say I use this equation. Okay, so this is the rate of change of momentum. Correct? Rate of change of momentum is directly proportional to the force, and it is applied that it will move with the same direction with the applied force. Okay, so that's the Newton's second law of motion. Okay, so I hope you can understand. Okay, okay, so I repeat again. Okay, so first, this one I already explained how you get the formula here. Okay, and then I already explained the acceleration is come from the formula of acceleration, that is v minus u divided by t. Then I expand the equation here, so I will get mv minus mu divided by t. Okay, so mv minus mu divided by t is actually the change of momentum, right? The final momentum minus with the initial momentum, so that is a change of momentum. Okay, so this one is actually change of momentum. So change of momentum divide by time. So anything that divide by time, so the formula you should start with rate. So rate of change of momentum. Okay, so rate of change of momentum. Okay, so then we learn the Newton's second law of motion. So Newton's second law of motion state that, okay, the rate of change of momentum here, the rate of change of momentum is directly proportional to the force, okay, and acts in the direction of the applied force. Okay, so let's say if the force, okay, acting on the object is to the right, means the object will move to the right. Okay, so it's like that. Okay, so what is the unit? Okay, so usually force, the unit must be in Newton. Okay, Newton. Or you can put here as a kg ms negative 2. Okay, or you can simplify it to Newton. Okay, so just remember the unit of the force. Okay, now we have the example. Okay, so how you want to calculate? Okay, by using the formula. Okay, by using the formula, F is equals to ma. So remember, F is equals to ma is Newton's second law. So Newton's first law is what? Is a inertia. Right? Okay, so let's try to answer this question. Okay, by using F is equals to ma. Okay, so for question number A, so force here is 8 and then the mass is 2. Okay, so what is the acceleration? So you will get 4. Okay, but don't forget put the unit here for ms negative 2. Okay, for B, okay, so this one you can see it has the same direction. So means, okay, we have to add these two force. Okay, so 14 plus 6 is 20. So the F is equals to ma. So F is 20, mass is 5. So the acceleration is 4 ms negative 2. Am I correct? Yeah. Okay. Sorry, this is for B. Okay, how about C? So you can see now the direction of the force is opposite direction. So if opposite direction, you have to minus to find the F net, the net force. Okay. So 18 minus 2. Okay. So the F net is 18 minus 2. So what is the F net? F net is a net force. Okay. So 18 minus 2, you will get 16. Okay. So then you can use the formula MA. So 16, M is 10, A is 16 divided by, 16 divided by 10, you will get 1.6 as ms negative 2. Okay. And then for D, since it has the opposite direction, okay, so you have to minus the force. Okay, so you have to minus the force. But this one, they got two force that acting to the right, 3 to the left, and one force only acting to the right. So you have to add these two force first. Okay, so 5 plus 5 is 10. Okay, because they have the same direction here, so we just simplify this force first. So 5 plus 5 is 10. Okay, so 5 10 to the right and also 10 to the left. Okay, so means F net is what? The F net is 0. Okay, 0 ms negative 2. So what happened to the object? So if the net force is 0, whether if the object is a constant in the if the object is at rest, it will remain at rest. Okay, so because the net force is 0. Okay, so this one we call it as a balanced force. Okay, balanced force. Okay, because we already know the effect for the unbalanced force is they can make the object accelerate, right, or moving or stop moving, right? Okay, so this one, because the F net is 0, means there is no net force here, so the object is in balanced force. This is a balanced force. So balanced force means if let's say the object is at rest, it will remain at rest. If the moving, it will stay moving with the uniform velocity. So that one we see later. Okay. Right. Okay. So for the next question, so a man, okay, push a trolley with a 5 kg box on a smooth surface. So remember when they say here smooth surface, you can ignore the friction, okay, the frictional force here. So if we use a force of 30 Newton to move the trolley, what is the magnitude and the direction of the trolley? What is the magnitude and also the direction of the acceleration of the trolley? So this one just use F is equals to ma. Okay, F is equals to ma. Remember, when you calculate something, please put the formula also. Okay, so F is 30, mass is 5. So the acceleration is 6 ms negative 2. So that will be the answer. So what is the direction? The direction will be same as the force applied to the box. So means it will move to the right. So remember to the Newton's second law just now, right? The rate of change of momentum is directly proportional to the mass. To the force. Okay. And the direction of the force is same as the direction of the force applied to the object. Okay, for number 3. An object of mass 2 kg is pulled on the floor, okay, by a force of 5 Newton and having a constant velocity. Okay, constant velocity means the object is in balance. Okay, so I just told you just now, if at rest or constant velocity, the object has a balance force. Alright, okay. So here, what is the frictional force between the object and the floor? Okay, so let's say I draw a diagram here. So this is the object and it has a mass of 2 kg and it pulled on the floor by a force of 5 Newton. Okay, so the question asks you, what is the frictional force? So remember, every force that you give to the object, there will be another force that opposes to the force that you apply. Okay, so means there is another force that, okay, that acting on the object, but in opposite direction. So what is this name? The name of the force here? Okay, the name of the force here is a frictional force. Okay, so that one is actually action reaction. Okay, that one is Newton's third law. Okay, so frictional force. So any object that you give the force, okay, any object that you apply force to it, okay, there will be another force, right, that will oppose the force that you give. So for this one, okay, if you push the if you push the box, okay, on the surface, okay, on the floor, okay, 5 Newton, there will be another force that will oppose the force. So in the opposite direction, so we call it as a frictional force. Okay, I think you already know this one. So how you can calculate the frictional force here? So I underline the word constant velocity. So constant velocity means, okay, the balance force, okay, the net force is 0. That is the balance force. The F net is 0. So what does it mean by F net is 0? Okay, means the force here, the force to the right is actually equals to the force to the left. Alright, the force to the right is actually equals to the force to the left. Okay, so means 5 minus 5, right? We get 0. So what is the frictional force here? The frictional force is 5 Newton. Why I said that? Because it's moving with constant velocity. If the constant velocity means the force now is balanced. Okay, it has a balanced force, or we say it as equilibrium. Okay, so when you reach the equilibrium, the F net is 0. Okay, the net force is 0. We already calculate just now, right? So F net is 0. So when the F net is 0, means the right force is same as the left force. So, and you know, F5 minus 5 is 0. So the frictional force is 5 Newton. Okay, and then calculate the acceleration of the object if the object is pulled by a 17 Newton. So now you know, if you push only using the 5 Newton of force, the object will not move because the object has the same value as the frictional force. The force that you give is actually the same value as the frictional force. So the object will not move. Okay, it has to overcome the frictional force first, then it can move. Okay, you have to remember that. Okay, for an object to move, if there has a frictional force, okay, they have to overcome the frictional force first, then it can move, right? So for this one, if you put 5 Newton and the frictional force is 5 also, and when you minus it, because you know I already told you when the direction is opposite, okay, if you want to find the F net, you have to minus. So 5 minus 5 is 0. So there is no more force. Okay, so the object, if it's at rest, it will remain at rest. If it moves with constant velocity, it will move with constant velocity. There is no acceleration here. Okay, so in order for you to make the object accelerate, you have to push it more than 5 Newton. So for this one, they push with 17 Newton. Okay, so remember, you have to overcome the frictional force first, right? So you have to minus first, 17 minus 5, right? So 17 minus 5, so you will get 12 Newton. So this 12 Newton that we use to accelerate. Okay, so use the formula. F net is ma. Okay, so 12. The mass here is 2. And this acceleration is 6. So 6 ms negative 2. So this is the acceleration. Okay, So remember, when we mention about the constant velocity, you know the F net is 0. When the F net is 0 means, okay, the object, the force to the left is actually equals to force to the right. Okay, so if it has the frictional force, means the frictional force is same as the value of the force that you apply to the object. Okay, same like this one. Okay, like this one, you move with the opposite, right? So if you want to find the F net, you have to minus first. Okay, and this one, okay, I ask you to add these two force first. So because they have the same direction, so this one you get 10, and then this one to the right also 10. So 10 minus 10 you get 0. So this one means the object is in balance. Okay, or you can say it reached the equilibrium. Okay, I hope you understand that one. So if you don't understand, you can text me. Okay, so that's all for force. Okay, that's all for force. Okay, I want you to do the tutorial. Okay, tutorial for 2.6 force. Okay, I already give you. Okay, then maybe we can discuss in our next class. Okay, but maybe not tomorrow, because tomorrow I want to teach you how to answer paper 2. Okay, paper 2, and also I think maybe I want to discuss about paper 3. Okay, a little bit. Okay, for to help you to answer your Amadi, right? Your practical exam, okay, next year. So we have to be prepared from this year. Okay. So we move on to the next one, that is 2.7. Okay, so 2.7. Impulse and impulsive force. Okay. So a very familiar example, okay, that we can see, right? So let's say when you jump from the high place, okay, when you jump from the high place, so what your leg will do? It will bend, right? Just like suddenly like that, you don't have to like control it. It's like a reflex, right? Suddenly your leg is bent. Why? Okay, it's to increase the impact of time. So why you have to increase the impact of time? So you can decrease the force. Okay, so that is the example of the impulsive force. Okay, so this is another example. So in an accident, okay, the force which acted can cause a severe damage and also injuries. The strong force acted in a short time interval is known as impulsive force. Okay, so this is the impulsive force, the example of an impulsive force. So there's a lot of example of impulsive force. Okay, like the one that I told you, when you jump from the high place, okay, your leg suddenly just bend. Okay, that one is to increase the time impact, so it will decrease the impulsive force. So you can imagine what happen if your leg don't bend, okay, when you jump from the high place. Okay, so of course I think your leg will be broken, right? So that is actually why, okay, your leg is bent. That one is actually to reduce the impulsive force. Okay, so this is the exercise 1. Okay, given F is the impulsive force. Okay, M is the mass, U is the initial velocity, T is time, V is the final velocity. Okay, so we see number 1 first. Okay, from equation F equals to ma that we learned just now. Okay, rate of change of momentum. We derive the equation for impulsive force. Okay, so this is F is equals to ma. A is P minus U divided by T. Then we expand it. You got mv minus mu divided by T. And I already told you this is the final momentum. This is initial momentum. So if we simplify it, it will become change of momentum. Okay, and then we divide by time. So the next one you get rate of change of time, rate of change of momentum. Okay, because it divide by time, right? So I already show you that everything that we divide with time, the formula we divide it with time. The meaning we start with rate. So rate of change of displacement, right? Rate of change of velocity. So all of that we have to divide by time in the formula. Okay, so this is the rate of change of momentum. So what is the meaning of impulsive force? Okay, so impulsive force is actually rate of change of momentum. So that's the meaning of the impulsive force. So actually, the one that we learned just now in the Newton's second law, right? The rate of change of momentum is directly proportional to the force applied, right? So that one is actually the rate of change of momentum is the impulsive force. Okay, that is the impulsive force. So rate of change of momentum, this is the meaning, or you can say force act in a short time during collision or explosion. But in exam, usually they accept this one as the answer. Okay, rate of change of momentum, and that one, the sentence is much simplified than the other one, right? So you just remember impulsive force, rate of change of momentum. Okay, from equation which is derived in question 1, so derive an equation for change of momentum. Okay, so F is equals to mv minus mu divided by t. Okay, so if you want change of momentum, okay, you just have to, okay, move the t here to this side, right? So it will become ft minus ft equals to mv minus mu, because we only want the change of momentum. So this is the change of momentum. Final momentum minus with the initial momentum. Okay, so you got another equation. Okay, so ft is equals to mv minus mu. Okay, so what does it mean by impulse? Change of momentum. Final momentum minus with initial momentum. That is a change of momentum. So another name for change of momentum is impulse. Just now, right, we learned about Newton's second law. That is a rate of change of momentum is directly proportional to the force. Okay, so actually the rate of change of momentum, we call it as a impulsive force. Right, and the formula is F is equals to mv minus mu divided by t. Okay, so this is the the ball to move with a high velocity. I mean high velocity means high change. Alright, so now we see for the Newton's third law of motion. Okay, so this one actually I already stated just now, right? Remember when I said that every object that you apply the force to it, okay, there will be another force that will act, okay, on the object but in opposite direction. Okay, so that is called as the action-reaction. So that is a Newton's third law. Okay, so for every action, there is a reaction of equal magnitude but in opposite direction. Okay, so let's say for this one, when you pull the wall, so you pull to the right, okay, the reaction will go to the left. Okay, or this one, if you pull the rock, okay, that's another force that acting on the man. Okay, that is, we call it as a frictional force. Okay, and this one, a rocket, like a momentum just now. We learned on last week, you learned with Mr. Jim last week, right? Okay, so reaction and action. The action here, okay, you know, in the combustion chamber, okay, there will be a gas, right? A kerosene gas we mix with the air, and we form the combustion, and we'll form a combustion here, right? Then there will be high velocity of gas going down. Okay, as a reaction, there will be an upward force, right? With the same magnitude, okay, that we go upward. Okay, so that is the action reaction. The velocity of the gas, the high velocity of gas will go downward. And as the, you know, the principle conservation of momentum said what? Okay, there will be another force, right? Since the force, there will be a force with the same magnitude, okay, that will act and it will move upward. Okay, so the force is same. So this also is action reaction. Okay. So increase the magnitude of impulse by follow through action. Okay, so this one in the video we see, and also in the football. Okay, they just take the leg. Okay, they move backward a little, the leg. Okay, so this one is actually to increase the velocity. So when the velocity increase, okay, the change in momentum also will become larger. So the ball will go further. Okay, the ball will go further, and also it will move with the high velocity. Okay, state two physical quantity which can produce large change on momentum or impulse. So the first one is force also, and also time. Okay, force and also time. Because you know the change of momentum is impulse. What is the formula for impulse? Ft, right? So force and time. Okay, so explain why the football player throws the ball as shown in the diagram 1. Okay, so why it moves slightly backward? Okay, so it will take a long time, right? If you push the ball backward a little, you will have the long time. So when the long time, the Ft will be large. So the impulse large, the change of momentum also will be large. Okay, and the ball can move with the high velocity. So Ft is equals to mv minus mu. So when the time is increased, okay, the Ft also will become increased. Alright. So when the Ft increase, the velocity here also will become increased. So it will move with higher velocity. So when it move with higher velocity, it will move further.
Football, as you may have guessed, is a game you usually play with your feet. But when it comes to throw-ins, footballers get the chance to show off their handiwork too.
What a throw-in!
They're not just an essential set piece, they can also be used as a dangerous weapon, as today's top 10 will show you. We can't wait to hear what you think of the best Bundesliga goals scored from throw-ins. Our countdown begins with Theophanis Gekas. The Greek striker had a great nose for goal and showed it here against Stuttgart, nodding home for his throw.
Oh, they let him through! And there is Theophanis Gekas with his 5th of the season. Nobody picked up the runner. And it's simple from there for a man of Gekas' qualities. What were Del Pierre and Taski doing? Keeper can't do anything.
In 9th place we have the king of throw-ins, Harold Kartemann. The former Dusseldorf player grabbed 8 assists in his Bundesliga career, with an incredible 5 of them coming with his hands. His first appearance in our countdown set up the goal for Richard Zillon against Bremen back in the 1995-96 season, although he also had a little help from the post. Schalke's former long throw specialist Christian Fuchs is up next. His ball in finds Jefferson Farfan, who applies the coolest of finishes.
Chance for Farfan, and Farfan scores! The Bundesliga's first goal of the year. Jefferson Farfan with a fine shot books the home.
So we move on to the next one. So it asks you to state the relationship between the impulsive force and the time of impact. Okay, so it will inversely proportional. So impulsive force, this is the formula. Okay, so I hope you're not confused with impulsive force and impulse. This is formula for impulsive force. This is formula for impulse. Okay, so this one is for impulsive force. So asking you the relationship between impulsive force and the time of impact. So when the force increase, the time will decrease. So this is inversely proportional. Right, and then the impulsive force, whether it's high or low. Okay, so if the time is high, okay, the time is high or it has a longer period, okay, the force will decrease. Okay, so means it will produce a small impulsive force. If the time of the period is shorter, okay, the force will be increased. So it produce the big, okay, or high impulsive force. Okay, so the next one, okay, so you have to hit a table slowly with your hand. Is impulsive force act on your hand big or small? Okay, so only a very slow one. Okay, you hit with your hand with the table with your hand. Okay, all right, and then you can see the impulsive force is small. Okay, now you try to hit harder. Okay, so you have to describe what happened to your hands in terms of impulsive force. So you will feel painful. Okay, so and another one. Okay, so it say here painful. Why? So contact time with the hand with the table is shorter. Okay, so it produce the high impulsive force. Okay, actually the impulsive force is similar as feel painful. So when the impulsive force is high, you will feel more painful. Okay, so this one is for C. Okay, so you have to quick, very hit the table faster. So means the time here is lower. So when the time is lower, the impulsive force is higher. Okay, so that's why you feel painful. Okay, so actually impulsive force is similar like feeling painful. So high impulsive force means it's more painful. Okay, for number 3, so this one you can do an activity to catch a ball to study the effect of the impulsive force. So you have to stop a ball with your hand which does not hurt you. So explain the method to reduce the pain on your hand. Okay, so for this one you just catch the ball. Okay, and then the next one you will slightly move backward. Okay, your hand slightly move backward when you catch the ball. Okay, so how you want to reduce the pain? Okay, means you know you have to increase the time of impact, right? So if you want to move, you want to decrease the impulsive force here. Okay, you want to decrease the impulsive force, you have to increase the impact of time. So the way to increase the impact of time, you have to increase the time for you to catch the ball. So you will just slightly move backward. Okay, so the time will increase. Okay, so this is the situation. So let's say a high jumper lands on the thick mattress. So why you use a thick mattress? Okay, so this one to increase the impact time. Okay, so it will reduce the impulsive force. Okay, and why the goalkeeper will wear a glove to catch a ball? So this one is to reduce the impulsive force. Okay, so the time interval for the impact when they catch the ball will extended. Okay, and the impulsive force will be reduced. Okay, and this one I already told you. Let's say a long jumper will bend his leg upon landing. Okay, so this one, if even you also, if you jump, okay, you will bend your leg. So why? So this one to increase the impact time, so the impulsive force will be reduced. And for the softball player, okay, so you must catch the ball in the direction of the motion of the ball. So this one is to extend the time of impact. Why? So this one to reduce the impulsive force. Okay. And another example, items that are fragile, okay, such as eggs, glass, and electrical appliances. Okay, must be packed in material that are soft and compressible. Why? So this one is to reduce the impulsive force. So the time interval of impact is extended. So it does not break easily. Okay, so this one is when the impulsive force is needed. Okay, for this one means is the negative one, the negative effect. Okay, but for this one is the positive one, where you need the impulsive force. So for the impulsive force, a karate expert can break a thick wooden slab with his bare hand that move at a very fast speed. Okay, this one you have to make your time, the length of the time impact is decreased. Okay, so you can produce high impulsive force. Okay, this one they have to use this formula. Okay, low time of impact, high impulsive force. So that one, they can break the wooden. Okay, for the karate. Okay, and then the next one is a massive hammerhead moving at a fast speed is brought to rest upon hitting the nail. So the time of contact between the hammer and head nail are short. Okay, so when the time is decreased, the force will be increased. Okay, so then the nail can move into the wall easily. Okay, because it has a high impulsive force here. Okay, the next one, a football must have enough air pressure in it. Okay, so this one to reduce the time of impact, so the impulsive force is bigger and it will move further and faster. Okay, this one, a pestle and a mortar, they are made from stone. Why they don't make it using a sponge or something soft material? So because if stone means the time of impact will decrease, so the large impulsive force will be produced. So it can make these spices to be crushed easily. Okay, so let's see for the exercise number 2. Okay, Mota Dahari, right? Mota Dahari kicks a ball with a force of 1,500 Newton. The time of contact of his boots with the ball is 0.01 second. So what is the impulse delivered to the ball? Okay, if the mass of the ball is 0.5 kg, what is the velocity of the ball? Okay, so this one you have to be careful. They want you to find impulse. So what is the formula of impulse? Ft is equals to mv minus mu. Okay, so it gives you force already 1,500 and it gives you the time 0.01. Okay, and then they give you the mass here 0.5 kg, and then they ask you also to find the velocity other than impulse. So impulse you already know, you have to use whether this one or this one. Just choose one only. Okay, if you want to find impulse. So based on the information given, so means you can only use this one. Okay, Ft. So 1,500 multiplied by 0.01. Okay, so you use your calculator. Sorry. So you will get 50 Newton second. So that's the formula, that's the unit for the impulse. Okay, so this is impulse. Okay, the next one asks you to find the velocity. So you already know impulse here, right? So you know Ft already. So I just can replace. This is the formula. I already find the Ft here. So Ft is 15. The mass is 0.5. Okay. So this is the final velocity is v. Okay. And 0.5. Okay. So we assume that the ball is at rest. Okay. First, so 0. Okay, so you will get 0.5 V 15. So V is 15 divided by 0.5. You will get 30 ms negative 1. Okay, so that's how you want to find the answer. So all this formula you have to remember. Okay, because since you are new batch of KSSM, right? I mean, I'm not sure how's your paper. Okay, you have to wait for this year SPM. Okay, to see whether what formula they will give to you, right? And sometimes when if they give, cannot use it. Okay, it's useless. Okay, so that's why I say every formula you have to remember. So since you just start, okay, you just start like chapter 2 now, so it's still early for you. You still can memorize. Okay, rather if you like waiting for form 5, then you want to remember all. Then I'm not sure whether you can remember all of it. Okay, so just start from now. Okay, if you want to be excellent, you have to start earlier. Okay, this is not PT3. Okay, this is SPM. Okay, so and you are new format, so everything can happen. Okay, now especially in the COVID time, right? So we don't know what happened. Okay, so that's why I said start from now. Okay, if you want to get a good result. Okay, for number 2. In a tennis match, a player hits an oncoming ball with a mass of 0.2 kg and velocity of 20 meters per second. The ball rebounds, okay, with a velocity of 40 ms negative 1. Okay, the time taken in the collision between the ball and the tennis racket is 0.01 seconds. So what is the impulse experienced by the ball? Okay, for this one, first one what I can say, you have to take all the info given. Okay, So we have a mass here. Okay, and then the initial velocity is 20. Okay, and it will rebounds back with 40 ms negative 1. But remember, since the opposite, I move in the opposite direction, so v is negative 40. Okay, so you have to be very careful. Okay, on the direction, you have to see very carefully what is the direction. Okay, so v is a negative 40. Okay, and then the time here is 0.01. The question asks you to find impulse. So we write the formula of impulsive. Okay, based on the information given, you cannot use ft because there is no force given. Only they give you the time, right? But they give you the v and they give you a u, and you also have m. So mean you can use this for this side. Okay, so it means it doesn't matter. Like let's say this is actually the formula for impulse. So it doesn't mean that you have to use both of it. Okay, sometimes you can only use one of it. It depends on the information that given by the question. So mv minus mu. So 0.2, v is negative 40, m is 0.2, u is 20. Okay, so use your calculator. 0.2 minus, multiply by negative 40. Okay, minus 0.2, 20. So you will get negative 12 Newton second. Okay, so that's the impulse. The next question asks you to find the impulsive force. So this is the formula. Okay, so this one, do I need to calculate again? No need, because mv minus mu already calculate here, right? So we just directly use the answer. Okay, so this one I have to divide by 0.0. So it become negative 1200 Newton. So that's the answer. The negative is actually to show the direction. Okay, the negative. Okay. Okay, for number 3. Okay, so Ali with a mass of 60 kg jumps from the first floor of burning house. Okay, so his velocity just before landing on the ground is 6 meters per second. So the first one asks you to find the impulse. Okay, so impulse, that is Ft. Okay, this one I put here. Okay, the answer. Okay, you cannot use Ft because they didn't give you any time here. Okay, they just give you the mass and also they give you the velocity. Okay, the final velocity, that is 6. Okay, then we know before it's jump, of course the u is 0. Okay, it at rest, right? So you have to use this one. 66. Okay, 60 multiplied by 0, so you will get 360 Newton second. Okay, so that's the answer for A. For B, what is the impulsive force on the resident's leg? Okay, legs if he bends before landing and takes 0.5 to stop. So impulsive force, that is F is equals to mv minus mu divided by T. So do I need to calculate mv minus mu anymore? No need, because I already have this one. Okay, I already calculated before. So 360, so the time is 0.5. Okay, so 360 divided by 0.5, we get 720 Newton. Okay, that is answer for B. The next one, so what is the impulsive force on the resident leg if it does not bend and stop in 0.05 seconds? Okay, so we use the same one, okay, but we only change the time here. Okay, so 360 divided by 0.05. Okay, so 360 divided by 0.05, you will get 7,200 meters. So you can see the impulsive force become increase. Okay, since the time becomes smaller. Okay, the time becomes shorter, the impulsive force is increased. So what is the advantage of the bending his leg upon landing? Okay, So actually this one to increase time of impact and reduce the impulsive force. Okay, so I think I finished already for force and also impulsive force. Right, so you can do the tutorial, okay, for 2.6 and 2.7. Okay, so I will stop here and see you tomorrow. So tomorrow we discuss for the how to answer paper 2. Okay, I will give you how the technique. Okay, some of you already afraid because AC. Okay, when you heard the word AC, you imagine that you have to write like karangan like that, like BM1. Okay, so no, it's not like that. Okay, so we see tomorrow. Okay, so thank you for now. Okay, so take care. Please do answer the tutorial. Okay, so if you have any question, you can text me. So I'm really sorry I can do the online class, but I hope what I teach today you can understand. If you have any question you don't understand, please do ask. Okay, right, so thank you. Bye.